Now we're going to pick up where we left off. So this is the problem we had just solved. It takes Bob 3 days to paint a house. It takes Ralph 2 days to paint a house. We found out how long it takes for them to paint a house together. Okay, and it was 6/5 of a day. What if we continue on that problem with this? What if Bob paints for 1 day before Ralph joins him? All right. So here's our picture of the house. And what's happening here? Well, Bob paints for 1 day. So remember, we know that Bob's rate, let's put it over here, is one house in 3 days, or 1/3 of a house in 3 days. So this is actually 1/3 of a house. And Ralph's rate was one house in 2 days, or half a house in a day. So this entire thing is the entire house. So it's this 2/3 of a house that still needs to be painted, right? One entire house, Bob paints the first third, one house in 3 days. So if we multiply this by 1 day, we get 1/3 of a house, leaving 2/3 of a house. So the problem is still basically what we had before. So 1/3 times the time spent, this will now be the time for this, okay? Plus 1/2 t equals 2/3 of a house. So like before, 1/3 plus 1/2 t equals 2/3. This becomes 2/6 plus 3/6. T is equal to 2/3. Five 6 t equals 2/3. And so t is equal to 6/5 of 2/3. By 3 you get 2, which is 4/5 days. Of course, I said, what if Bob does this? I didn't actually ask what's the underlying question we're answering. So if the question is, how long does it take to paint the entire house? Remember, this was 1 day. So entire house is equal to 1 day that Bob was by himself, plus 4/5 days where they work together. So 5/5 and 4/5 would be 9/5 total. Okay? Let's look at a slightly different version of this. What if Bob paints twice as long as Ralph? So this is not an extension of the problem we just did. We're basically going back to the original problem of painting the entire house. But the time that Bob devotes is twice what Ralph devotes. So now we'll have this. T1 equals Bob's time. T2 equals Ralph's time. And so our expression becomes 1/3 of T1 plus 1/2 of T2 is equal to 1 total house. We got 2 variables here, right? 2 different variables. When we solved the original problem, we knew the times were the same, so we just replaced both these by t. Now they're not the same. So what's the relationship here? Bob paints twice as long as Ralph. So this is where I would do spot checking. So I might say, well, if Ralph spent a day, then Bob should spend 2 days, right? So it'll be T1 is equal to 2T2. I checked that. If T2 is a day, T1 would be 2 days. Yeah, 2 days is twice as long as 1 day. So that seems to make sense. Here's my second relationship. Now I could either leave it like this, or I could say T2 is equal 1/2 T1. Either one would work. So I'm actually going to use this. So now our equation becomes 1/3 T1 plus 1/2 times 1/2 T1 is equal to 1. So I have 1/3 T1 plus 1/4 T1 is equal to 1. 1/3 plus 1/4 of T1 is equal to 1. 4 over 4 will give me 4/12. 3 over 3 will give me 3/12. So T1, so this right here is 7/12. So T1 then will be equal to 12/7 days. Okay. And so then what is T2? T2 is equal to 1/2 of this. Six-sevenths days. So these are the two values. Okay? So hopefully that makes sense. I'll do another video. In fact, let's just go ahead and do it now to show you something. We'll just pick up on where we our momentum here. So let's say we have this problem. We have two cities. I'll go ahead and just draw the picture. City A, City B, and they're connected by a railroad line. So this is 300 miles. So a train leaves A going towards B at 100 miles per hour. And a train leaves B going towards A at 50 miles per hour. So how do we set this up? Well, it's really basically the same thing we had before. This is moving faster, so it's going to be somewhere in here. So if we talk about our domain knowledge, what do we have here? Well, we have miles per hour times hours equals our distance or our amount, right, in miles. If we think back to our very first problem that I did with the rates of painting, it was the same thing. Here's the rate, here's the time, here's the amount. So the problem is basically the same. If we assume they both start at the same time, then we can just say this: 100 miles per hour times the time in hours plus 50 miles per hour times the time in hours is equal to 300 miles. In our painting problem, we were trying to complete one house, so the amount was one house. Here we're completing a total distance of 300 miles, so that's what we use here. So 100 miles per hour plus 50 miles per hour will be 150. If we want to keep it as a fraction, it'd be like this, times t equals 300. Okay, so we get t is 300 divided by 150, which is 2 hours. So it takes 2 hours before they meet. Does that make sense? Well, let's think about it. First one goes 100 miles per hour. So 100 miles per hour times 2 hours is 200 miles. The second one goes 50 miles per hour times 2 hours, which is 100 miles. Together, that's 300 miles. So this is the 100, here's the 200. So it's basically the same thing we did. So most of the things that we did, in fact, I guess all the things we did in our previous examples, there'd be some version of that that would apply to the same problem, because conceptually it's the same thing.